Okay, everyone, let's jump back in. Question 41. Evaluate the defined integral from 1 to 2 of 5x dx. That's going to give us 5x squared over 2. And we're evaluating from 2 to 1. So that's going to be 5 times 2 squared over 2. Oops, minus 5 times 1 squared over 2. This is 5 times 4, which is 20, divided by 2, which is 10. We can just leave 20 over 2. Minus 5 times 1 is 5 over 2, so that's going to be 15 over 2, which is 7.5. Okay, 42. We're evaluating 1 to 2 of x dx. That's going to give us x squared over 2 from 1 to 2. So that's 2 squared over 2 minus 1 squared over 2, which is going to be 4 over 2 minus 1 over 2, which is 3 over 2, or 1.5. Oh, sorry, I was out of frame on that one. Okay. 43. We have integral from 5 to 6 of 9 over x squared dx. That's going to give us 9x negative 2. Our result is going to be 9x to the negative 1 over negative 1, 5 over 6, to be negative 9 over x. So negative 9 over 6 minus negative 9 over 5, which is going to give us 3 over 10. Alrighty. Now 44. Integrating 6 to 1 for 2x plus 1. That's going to give us 2x squared over 2 plus 4x. Reduce that. It's going to give us x squared minus 4x. And then when we evaluate, it's going to give us 1 squared minus 4 minus 6 squared minus 4 times 6. Equals 1 minus 4 minus, give me a second. Okay, scratch that. I realized I made a mistake. Let's do 44 over again. All right, 44. Integral from 6 to 1 of 2x plus 1 dx. equals 2x squared over 2 plus 1x. This is going to reduce to x squared plus x. Okay, that's better. So 1 squared plus 1 minus 6 squared plus 6. This is 2 minus 36 plus 6. So that's 2 minus 42 equals negative 40. All right, that's much better. 45. I was looking at it, I was like, there's something wrong here. I made a mistake. Okay, 45. Evaluate 0 to 3 of e to the 3x dx. So here we are using some of our u substitutions. So u equals 3x du dx equals 3 du equals 3 dx. So I need to force this. So I'm going to add my 3 over 3 in here. Okay. So this ends up giving me the integral 0 to 3 e to the u over 3. And then this 3 times dx gets wrapped into your du. Okay, so then the result is the integral from 0 to 3 of e to the 3x over 3. So we're going to evaluate e to 3 times 3 over 3 minus e 3 times 0 over 3. That's going to give us 2701.028 minus 0.333, which is going to give us rounded to the thousandth. 2701. 2700.695. So here we're going back to our u substitutions and making sure we account for the missing parts by, here we needed the 3, so we included the 3 over 3 fraction, which isn't changing anything, but it gives us the appropriate form to account for the du substitution. And then we have the remaining 3 in the denominator. So don't forget to do that work. Okay. So we got 46. Okay. 46. Find the area bounded by the graphs of the indicated equations over the given interval. So our equation is y equals negative 8x minus 9 and y equals 0. And we're evaluating over the interval -1 to 2. So I'm going to graph this first. Negative 8x, oops. Negative 8x minus 9 and 0. Graph. I actually need to change my window. So let's make this -2 to 2, -20 to 20. All right, so here, -2, no 2, we can do a little bit further, -40. Okay, so here from our interval -1 to 2, we can see that our graph is below the x-axis, so that's in the negative space. And so because this problem is specifically asking us for area cannot be negative. So we need to account for that negative once we complete our integration process, right? Our integral process. Okay, so we're gonna integrate from -1 to 2, -8x minus 9, which is going to give us -8x squared over 2 minus 9x. Yeah, okay, -1 to 2. Okay, so evaluating at 2, this is going to give us -8 2 squared over 2 minus 9 times 2 minus -8 -1 squared over 2 minus 9 times -1. So this is going to be -4 times 4 is -16 minus 18. This is going to be 1 times 8. So -8 divided by 2 is a -4. And -9 times -1 is +9. And so this is going to give us -16 minus 18 minus -4 plus, this is going to be +4 minus 9. So -16 minus 18 plus 4 minus 9, which is going to give us a -39. But again, remember, because we're operating, our graph is below the x-axis, we need to also multiply it by a -1. So that'll give us a +39. Okay, 30, 30, 47. Ooh. 47 y equals x squared minus 22, y equals 0, and we're evaluating over the interval from 3 to 0. Okay, so let's see what that looks like. Our y equals, type in our graph, x squared minus 22. We know our window is from -3 to 0. Let's graph that. Again, it's below the x-axis. So we're going to take -1 from -3, evaluate from -3 to 0 of the function x squared minus 22 equals x cubed over 3 minus 22x. So that's going to look like 0 cubed over 3 minus 22 times 0 minus -3 cubed over 3 minus 22 times 3. This term is going to go to 0. This term is going to go to 0. So we have -3 cubed is -27 over 3 minus 66. So that's going to give us -27. Oh, so divide that, right? So -9 minus 66 equals, I think I have a calculation error. Boo. Where did I make that calculation error? 66. 22 times 0 is 0. 0 cubed is 0 over 3. -27. Oh, dang. All right. 22x. You know, guys, I'm just killing it today. Oh, I forgot my negative right here. That's positive. Positive. Ooh, it's getting late. I'm losing negatives. All right. So -9 plus 66 equals 57. Yes. All right. So our area is equal to 57. I wanted to put dollars. Okay, 57. Oof, that got me all messed up. Okay. $48. Our function is y equals negative x squared y equals negative x squared plus 28, y equals 0, and we're evaluating from -3 to 3. So let's graph that. Negative x squared plus 28, negative x squared plus 28, and then we're going to change our window to -3, 3, graph. Graph is somewhere up here, so let's change our y max to maybe, let's go 40. Okay, perfect. So here everything is above the x-axis, so I don't need to account for that negative for this one. And we're just going to integrate from -3 to 3, negative x squared plus 28, which is going to equal negative x cubed over 3 plus 28x. And then that ends up giving me 75 minus 70 minus a negative 75, which is going to equal 150. All right, 49. This is minus a negative 75. Okay. Next. Okay, using production and geological data, the management of an oil company estimates that oil will be pumped from a producing field at a rate given by the following. R of T equals 90 over T plus 9 over the domain 0 less than or equal to T less than or equal to 15. R of T is the rate of production, thousands of barrels per year. T years after pumping begins, find the area between the graph of R and the t-axis over the interval from 5 to 11 and interpret the results. Okay, so we want to find the integral over 5 to 11 of 90 over t plus 9 plus 9. So if we break this down, we can look at it as 5. The interval from 5 to 11 of 90 over t plus 9 plus 9, 11, 5. So I'm just breaking this down into two pieces, essentially, right? So here, I just want to get this isolated. So it's going to be 11, 5, 1 over t plus 9 plus 9. Okay, and so the integral of this term, 1 over t plus 9, is going to give me 90 times the natural log absolute value of t plus 9, plus we know the integral of 9 is just going to be 9x, and we're going to evaluate all of this over from 5 to 11. Okay, so when I do that, I'm honestly just going to put this in the calculator and then evaluate at 5, evaluate at 11, and that's going to give me 368.6159 minus 282.51516, which equals 86 rounded, right? So it's 86.10074. We're rounding to 86. All right. We're almost done, friends. Okay, so then the final part of this question is interpret the results. So the total production from the end of the 5th year to the end of the 11th year will be approximately 86,000 barrels. Put a star by this. Make sure you understand the physical interpretation of what this answer represents, okay? All right, we made it. Question 50. Let's see what we got going on. An amusement company maintains records for each video game it installs in an arcade. Suppose that C of T and R of T represent the total accumulated cost and revenue T years after a particular game has been installed, and the derivatives C prime and R prime are the functions below. What is the useful life of the game? So useful life occurs when C prime equals R prime, okay? And they gave us those two equations. And so again, test taking skills, I'm not going to hand solve this. I'm going to plug those two equations into my calculator. So C prime of T equals 3 and R prime of T equals 7 e raised to the negative 0.3 t, and then I'm just going to clear that y equals 0 out, and I'm in a graph. And there we can see there is a point of intersection. So actually, let me change the window because again, we're in real space. So y x max, let's go 10. It should be good. Okay, so perfect. We can see that point of intersection through second, trace, intercept, enter, enter, enter. So the point of intersection is at 2.8. So rounded to the nearest 10th. So T equals 2.8. And find the area between the curves. So we're going to evaluate. Oh, okay, so here, y, let's go back to our graph. I'm going to change the window a little bit. Second trace, let's see, second trace 1, I want to know where we're at. 3, so window, the y max can really be like 5. Okay, so we're evaluating from 0 to 2.8, which is that point of intersection. So we want to find the area here. Okay, so what we need to know is, let me make this a little bit bigger. What we want to know is which graph is above and which graph is below. So we can go trace. The graph that is above is your revenue graph, and the graph below is your cost graph, which makes sense, right? Again, we want profitability, so the revenue is greater than the cost function. And even it holds true for your C prime and R prime. Okay, so we're going to evaluate from 0 to 2.8, and it's R prime minus C prime. So that's going to look like 7e raised to negative 0.3x minus 3. And then we're going to find the integral of this, and that's going to give us 2.8 of negative 7 over 0.3 e to the negative 0.3 x minus 3x. So here again, right, you should be doing some u substitutions. Your u is negative 0.3x, your du dx is negative 0.3. This is how you end up with this negative 0.3 in your denominator. Okay, so again, when we evaluate this, I'm going to plug this in the calculator, not doing it by hand. You're going to get negative 18.47 minus negative 23.33, and that's going to give you a total area of 4.86. Okay, and then interpreting that means the total profit from the game was $4,860 over its usable life. So again, remember that in the very beginning of the problem statement, it tells you that cost and revenue are measured in thousands of dollars. So this should be times 1,000, which is that 4,860. Okay. All right, guys, that is the end of our Math 1324 final exam review. As always, if you have any questions, please send me an email, let me know, and good luck to everyone on your final exam, and I hope everyone had an amazing semester and enjoy your time off once you're done. Bye.